Hello class, today we are going to learn about plate boundary types. So we just did a lesson which taught you that the Earth's crust is broken into multiple plates. So this lesson tells you what happens when the plates meet. What happens at those locations? So first you need to know that there are three different types of boundaries. There's divergent, where the plates move away from each other, convergent, where the plates move towards each other, and transform boundaries, where the plates slide past each other. The first one that we're going to talk about is divergent plate boundaries. Here the plates are moving away from one another. They occur above rising convection currents. The rising current pushes up on the bottom of the lithosphere, which is the layer of the asthenosphere and the crust, which consists of the moving plates. That is what the plates are called that move. So the current pushes up on the bottom, and then it flows parallel along the bottom of the plates. So the flow, which is flowing parallel to the plates, causes the plates above it to drag along in the direction of the flow. The overlying plate is stretched really thin until it breaks apart in a certain spot, and this is what caused the separation of the plates. The magma rises through the cracks, which are also called fissures, and become part of the crust. So as the magma goes up through the cracks, it solidifies and becomes new oceanic crust or continental. So on the bottom here, you can see two animations which show the two different types of divergent plate boundaries. The first one we're going to look at is the oceanic divergent plate boundaries. A great example of this is the Mid-Atlantic Ridge. All of the oceans are actually connected by a ridge system where there's separation between the oceanic plates. So this creates a sort of underwater mountain, like a whole mountain range along the whole ridge. The volcanic activity occurs in the form of fissures, which are the cracks in the crust, which we just learned about, and it causes some minor eruptions. There is slight earthquake activity that occurs here. There's creation of new sea floor, and there is a widening ocean basin. So right here you can see the convection currents coming up, going along parallel along the bottom of this plate, and then it pulls these two plates apart, and so you can see right here the cracks are forming, melting occurs, and it fills up with magma. Now we're going to look at the continental divergent plate boundaries. A good example of this is the East African Rift Valley, which I'll show you a picture of in a minute. The Rift Valley is sometimes occupied by long linear lakes or shallow arms of the ocean. So you can see right here, when the crust separates like this, when it's continental crust that's thicker than oceanic crust, it causes some fractures right here, and it causes a little depression which can fill with water. So there are also numerous faults in the central Rift Valley, which these are the fractures right here. Those are faults, which we're going to learn about tomorrow. And there's slight earthquake activity along the faults, and volcanic activity can sometimes occur within the rift, which you can see the little dots right there. Sometimes the magma can reach the surface. So right here again you can see the convection current rising, going parallel along the bottom, and actually pulling these plates apart, because the convection current is right here. So it actually pulls these two separate pieces apart. This is an example of oceanic ridge. Right here you can see on this map that it goes along in all the oceans actually. This is the Mid-Atlantic Ridge specifically. It's in the Atlantic in the middle, as the name implies, and it splits the whole Earth in half like that. Isn't that cool? And then here is a picture of what it looks like underwater. This is the underwater mountain, this is the hot magma, and it can come up through these cracks. Here's a picture of the East African Rift, and this is right where the plates are separating in Africa, and it's causing some of those depressions that we saw on the other slide, which is like, it looks like this, just like the picture, with the fractures, which are also called faults. And you can see that this could possibly fill up with water. The next plate boundary is the convergent plate boundary. This is when lithospheric plates move towards each other. The plate collisions that occur can produce earthquakes, volcanic activity, and crustal deformation. So if you think about it, if two plates are being pulled apart, put your hands together with your fingertips touching and pull them apart like a divergent plate boundary. What happens at the end of your hands by your wrists? They would be going towards each other if they were on a sphere, right? So a convergent plate boundary between oceanic and continental plates. The thicker but less dense continental plate goes on top of the thinner, more dense oceanic plate. So if you think about it, the more dense plate would typically go below the less dense plate because it's more dense. The oceanic plate is forced down into the mantle in a process known as subduction. So subduction is going to be an important word here. This is when one plate is forced below another one. As the oceanic plate goes down, it reaches higher temperatures until it begins to partially melt, which you can see right here. This is going atop the other one. This one's sinking below. And then they're going to show some melt occurring where it's getting really hot. It's melting. Then it shows you that it's cool here, warmer here, and then it gets hot here. And this causes this plate to melt, and the less dense magma rises through this crust right here. And these are called magma chambers. These are little pockets of magma within the crust. If the magma chambers are still molten when they reach the top like this, then volcanic activity can occur. So oceanic and continental plate boundaries. The Washington-Oregon coastline of the United States is a good example of this. You can see it in the picture right down here. This California is right below here. This is the coastline right here. The Juan de Fuca plate, you can see this arrow indicates that it is going underneath the North American plate because this is oceanic. You can see the ocean on top, and this is continental. So this causes a Cascade Mountain range, which is the line of volcanoes above the melting oceanic plate. So right here, you can see all the volcanoes right where the oceanic plate is underneath the continental plate. Another example is the Andes Mountain range of western South America. And here, the Nazca plate, which is right here, the oceanic plate, is subducting beneath the South American plate. So you can see the South American plate here, and it's going under. And you can see volcanic activity, and it causes this Andes mountain range. Convergent plate boundary between two oceanic plates. When two oceanic plates converge, one of the plates will subduct beneath the other. Usually this is the older plate because an older plate will be more dense. So like the oceanic continental convergence between the oceanic and continental plates, when there's oceanic plates, the subducting plate reaches a higher temperature, right, like this again, and the same thing occurs as in the last example that we looked at, where the magma chambers rise and they can reach the top and volcanic activity occurs. Now first the volcano will be underwater, and then as more and more magma rises to the top, it will turn into an island, and they will grow larger, and they can merge to create elongated land masses. An example of this is Japan. Everyone here has heard of Japan. Here is the island of Japan, and you can see right here the two plates, the Pacific plate and the Philippine plate, that are going under this Eurasian plate. It's all oceanic right here, and when they converge or come together, these plates go underneath and then they begin to melt, and you can see all the volcanic activity right here and how it's combined to form an island arc. Also the Aleutian Islands and the Eastern Caribbean islands of Martinique. And these are some examples of what they look like. They're very beautiful. So next we're going to talk about convergent plate boundaries between two continental plates. Now this is the most difficult plate boundary to explain because it is less studied than the other ones. It's harder to study. But we do know that a very powerful collision occurs when two of these massive continental plates converge. So both of them are very thick, and they have a density that is much lower than the mantle. So this causes it not to subduct because it's lighter than the mantle, so it's going to stay on the top. There's not going to be any subduction that occurs here. There may be a small amount of subduction, but it's not commonly associated with this type of boundary. So the rock that is caught between the collision becomes highly deformed. As you can see right here, it shows the two arrows coming together, and the rock is just breaking. It's just going to break right along here. It's very deformed. The intense compression can also cause extensive folding, which you can see right here, and faulting of the rocks. So they actually fold, and this can lead to mountain ranges. The convergent plate boundary continental example would be the Himalayan mountain range. This is the best active example right now, so that means it's still forming sometimes, which is pretty cool. The two continental plates are coming together. This shows that some may have subducted, but it shows the collision right here and this huge mountain range. Our last plate boundary is called the transform plate boundary. The two plates slide past one another, and the fracture zone that forms a transform plate boundary is known as a transform fault. Most transform faults are found in the ocean basin and connect offsets in the mid-ocean ridges. So right here is a very common example. You can see the United States right here, and this is actually a plate boundary that occurs. And right here they're going to show us the way that it's sliding. Right here the arrows indicates that this plate is moving this way and this plate is moving this way. So these type of plate boundaries are associated with a lot of earthquakes. So right here, you know that in California and San Francisco there's a lot of earthquakes sometimes, so now you know why. And that is the end of the slideshow. We're going to do an activity when you come into class.